Welcome to the DIY Honda Garage channel. DTC P0191 indicates an issue with the fuel rail pressure sensor, specifically that the sensor is reporting pressure readings outside the expected parameters. The fuel rail pressure sensor is a critical component located on the fuel rail, which monitors the pressure of fuel delivered to the engine. It provides this information to the powertrain control module, PCM, allowing for optimal engine performance and fuel efficiency. Reading errors from this sensor can hinder vehicle operation, leading to performance issues or even the inability to start the vehicle. Proper diagnostics are essential to pinpoint the exact cause of the issue and ensure the engine operates efficiently. Understanding DTC P0191 is beneficial for technicians to effectively troubleshoot and resolve fuel delivery problems. The fuel rail pressure sensor plays a vital role in monitoring the fuel pressure within the fuel rail and delivers this critical data to the PCM. It is located on the fuel rail, which is part of the fuel delivery system. When vehicle performance issues arise, or when the PCM detects that the sensor readings are outside the normal range, it triggers DTC P0191. This code signifies that the input voltage is reading either excessively low or high, indicating potential sensor malfunction or wiring issues. Efficient communication between the fuel rail pressure sensor and the PCM is essential for the engine's performance, as it affects fuel delivery and combustion efficiency. Regular diagnostics can help maintain the proper functioning of this sensor, avoiding potential engine performance degradation. The potential causes of DTC P0191 can primarily be attributed to three areas. Firstly, a faulty fuel rail pressure sensor can lead to inconsistent readings, triggering the code. Additionally, wiring issues between the sensor and the PCM can disrupt the flow of information, resulting in erroneous voltage signals. This might manifest as either too low or too high voltage readings. Lastly, poor connections or loose terminals at the sensor or the PCM can further exacerbate communication problems. Thorough inspection of these components is crucial to determine the precise issue and proceed with effective resolution measures. Understanding these causes helps streamline troubleshooting and addresses underlying problems effectively. DTC P0191 can present several symptoms affecting the vehicle's overall performance. Notably, there are common engine performance issues that manifest, such as improper acceleration, reduced power output, or unexpected engine stalling. Additionally, drivers may experience difficulty starting the vehicle, as the engine may not receive the correct fuel pressure required for ignition. Misfires can also occur as a result of fuel delivery problems caused by erroneous readings from the pressure sensor. Identifying these symptoms early allows technicians to perform timely diagnostics and repairs, enhancing both vehicle reliability and performance. Addressing the symptoms associated with DTC P0191 helps ensure the vehicle operates as intended. The first troubleshooting step for DTC P0119 involves verifying the problem through initial diagnostics. Start by turning the vehicle to on mode without starting the engine, and utilize the Honda Diagnostic System, HDS, to check the input voltage from the fuel rail pressure sensor. Determine if the current conditions match the threshold values specified in the diagnostic protocol. For instance, if the input voltage is less than 0.21 volts, it confirms the failure, leading to the next troubleshooting step. Conversely, if the voltage is above that threshold, shift focus to the subsequent verification process. This step is essential in identifying the nature of the fault and sets the basis for further evaluation. Continuing the troubleshooting process, the second step involves another examination of the fuel rail pressure sensor's input voltage through the HDS. The objective is to see if the current conditions align with the threshold values, particularly if the voltage exceeds 4.99 volts. A confirmation of this condition suggests a duplicated failure, warranting further investigation into the wiring and connection integrity. In case the conditions do not meet the threshold, it could indicate an intermittent failure, meaning the system might be operational at the moment. In this instance, check for poor connections or loose terminals at both the fuel rail pressure sensor and the PCM. Regular maintenance of these components can prevent future issues related to electrical connectivity. In this step, the troubleshooting process moves forward by determining the potential failure area involving the fuel rail pressure sensor. First, turn the vehicle off and disconnect the fuel rail pressure sensor 3P connector. Following this, turn the vehicle to on mode again and utilize the HDS to check the sensor's input voltage readings. If the input voltage remains below 0.21 volts, it indicates a problematic sensor, and the next step should be pursued. Conversely, if the voltage is acceptable, proceed to diagnose further. This systematic approach ensures that the fault is accurately identified, significantly easing the repair process. The fourth troubleshooting step focuses on measuring voltage derived from the fuel rail pressure sensor. This involves assessing the voltage between designated test points on the sensor's connector while it remains disconnected. Specifically, voltage measurements should take place at terminals number 2 and number 3 of the fuel rail pressure sensor 3P connector. A reading of around 5.0 volts indicates that the wiring is functioning correctly and is indicative of potential sensor failure. If the expected voltage is not present, the next step will entail further diagnostics to identify whether the sensor itself should be replaced. Accurate voltage measurements are critical in the troubleshooting process, offering insights into the sensor's operational status. Next, we continue to the fifth troubleshooting step that targets the VCC1 wire. First, switch the vehicle to off mode and jump the SCS, service clear switch line, with the HDS. Waiting for more than 1 minute allows the system to reset before disconnecting the PCM connector E, ADP. Following these procedures, continuity must be checked between the fuel rail pressure sensor connector and designated test points on the PCM connector. If continuity is present, it confirms that the VCC1 wire is intact, necessitating checks for any service bulletins related to the DTC or symptoms. Should continuity not be detected, addressing the open circuit in the VCC1 wire is required, which is essential to restore proper sensor functionality and ensure reliable operation of the fuel pressure monitoring system. Step 6 delves deeper into diagnosing the PF wire for potential shorts. Begin by turning off the vehicle and jumping the SCS line again to ensure a proper reset. After this, disconnect the PCM connector and focus on testing continuity between the fuel rail pressure sensor connector and body ground. If continuity exists, it signifies that a short circuit is present in the PF wire. Conversely, if no continuity is detected, it verifies that the PF wire is functioning properly. The next recommended steps would involve checking for relevant service information pertaining to DTC P0191. If issues persist, substituting with a known good PCM may deduce whether the PCM itself is at fault, leading to efficient troubleshooting and repair processes. In the seventh troubleshooting step, assess the characteristics of the fuel rail pressure sensor directly to determine if it is functioning as intended. To do this, turn the vehicle off, disconnect the fuel rail pressure sensor connector, and utilize a jumper wire to connect terminals A and B of the connector. After establishing this connection, switch the ignition to on mode while continuing to monitor the input voltage with the HDS. If readings indicate a voltage exceeding 4.99 volts, it signifies that the sensor isn't the problem, and further investigation should continue. Alternatively, if no adequate voltage is detected, replacement of the fuel rail, specifically the pressure sensor, may be warranted. This method emphasizes efficient communication between components, ensuring the sensor operates effectively within the system. As we step into troubleshooting phase 8, the focus shifts back to measuring voltage under different conditions. Start by returning the vehicle to the off position and disconnect the jumper wire from the fuel rail pressure sensor's connector. Once this has been accomplished, activate the ignition to on mode and utilize a multimeter or the HDS to measure the voltage across the specified test points on the sensor terminals. Achieving a reading of approximately 5.0 volts indicates successful operation of the wiring. Failure to meet this electrical specification necessitates moving to troubleshooting step 9 to examine for possible open wire issues within the sensor circuit. This methodical approach to testing ensures that every component is thoroughly evaluated for functionality. In the 9th step of our troubleshooting protocol, attention is given to verifying the SG1 line's continuity for potential issues. Like previous steps, ensure the vehicle is switched to off and then jump the SCS line once more to reset. Disconnect the PCM connector E and check the continuity specifically between the indicated test points on the fuel rail pressure sensor and PCM. If continuity is confirmed, the SG1 line is functioning normally. Otherwise, investigate further for an open circuit that needs repair. Continual assessment of this wiring is crucial for effective sensor operation. Moreover, if repairs are implemented, verify that the DTC P0191 subsides, providing better insights into any lasting effectiveness of the solutions applied. Finally, we arrive at the last troubleshooting method, focusing on the PF line. Begin by turning the vehicle off before jumping the SCS line and disconnecting the PCM connector E. Continuity must then be checked between specific test points on the fuel rail pressure sensor connector and the PCM. If the PF wire shows continuity, it is essentially functioning properly, pushing focus back towards assessing the PCM for any related DTCs. Conversely, in cases where no continuity exists, an open circuit needs rectifying to ensure effective communication between the PCM and the fuel rail pressure sensor. These detailed examinations of the wire connections are crucial for eliminating any fault, ultimately leading to resolution and restoration of vehicle performance. After completing the troubleshooting steps for DTC P0191, it's essential to conduct a final verification to ensure all repairs were effective. First, use the Honda Diagnostic System, HDS, to confirm that any issues detected in previous steps have been resolved. Once verification is complete, proceed to clear all stored DTCs from the system to reset its monitoring capabilities. Following this, take the vehicle for a test drive under varying conditions to ensure that the vehicle operates within expected performance parameters without re-triggering the DTC. Continuous monitoring post-repair is necessary as it helps gauge overall effectiveness and provides insights on whether any further adjustments or repairs are required. This thorough verification process reinforces the confidence needed to ensure that repairs are sustainable. To mitigate potential triggers for DTC P0191 in the future, it is advisable to incorporate regular preventive maintenance checks. Scheduled inspections of the wiring associated with the fuel rail pressure sensor can help identify wear and tear before they lead to failure. Additionally, servicing fuel rail components will ensure they remain functional and effective in delivering accurate readings to the PCM. Cleaning and maintaining connection integrity at sensor and PCM connectors can also enhance vehicle reliability. Overall, consistent preventive maintenance is instrumental in preventing intermittent failures and can significantly enhance engine performance. Keeping these components in check promotes longevity and optimal functioning of the vehicle. In summary, DTC P0191 represents a significant concern with the fuel rail pressure sensor that requires systematic diagnosis and resolution. Understanding the causes and symptoms associated with this error code is essential for technicians to perform accurate troubleshooting. Each of the 10 steps outlined provides a comprehensive approach to diagnosing electrical issues related to the fuel rail pressure sensor, emphasizing the importance of proper electrical assessments. Final verification checks post-repair ensure that the vehicle operates correctly without reoccurrence of DTC P0191. Moreover, investing time in preventive maintenance can help avoid similar issues in the future. This structured approach not only enhances the vehicle's performance, but also provides peace of mind for the driver. Please like and subscribe to the channel. See you next time.